my dear students. Once again, very good more learning to all of you. So guys, what do I have today to talk with you? Yes, today I'm going to teach you a very important question of electricity, and that question is actually from NCERT Exemplar. As you know that NCERT Exemplar is very good book, or it has very good MCQs and questions to solve it, right? So for your board preparations, for your MCQs question, this book is very important. I strongly recommend it that you should follow that book. So what do I have? Let's see. Before going to the question, I would like to just introduce a formula which is going to use in that question. The formula and the physical quantity which is going to use here is power. So guys, the power or the electrical power, as you know, this is the work done divided by time, or the heat produced divided by time, or the heat per unit time. So what is the formula to calculate that power? As you can see on your screen, the formula of the power is 3. Here, V into I, one formula, another is I square R, second formula, and the last but not the least is the V square divided by R, where V is the electric potential between any two given points and R is the resistance, and similarly, as you can see, I is the electric current. So mainly we will use this formula, and the question which we are going to solve is actually related to electric bulb. The question that you can see on your screen is here. An electric circuit, 3 bulbs, bulb A, B and C of a reading and 40, 60 and 100 volt. So there are 3 bulbs having different wattage that is given in the question itself. And now you can say they are connected in parallel to an electric circuit. Which of the following is likely to happen means which of the following is correct. So guys, as you know, in parallel combination, voltage is going to be same. When the voltage is same, then how to find the brightness? So first thing is that you have to introduce here is that brightness. Right? So that brightness, because in all the option you can see brightness, 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 right? So you have to find the brightness, maximum brightness, then minimum brightness, or greater brightness or lower brightness that you have to check. So just see here that brightness I can represent by B is directly proportional to power, right? So if a bulb has more power, it will more bright. So now you can say to check the brightness, you have to check the power, actual power, not the rated power. So guys, just concentrate here that rated power and actual power are two different things. When we get the rated voltage, then only we will get the rated power. But if we will not get the rated voltage, then obviously we will not get the rated power. Then the actual power is different. Now, as they are connected in parallel. So this question is quite easy because of the combination is parallel. As they are connected in parallel, so all these 3 bulbs have the same voltage. And if they have the same voltage, so obviously you can compare their brightness by the power. So here, as you can see, power of A is 40 watt, power of B is 60 watt, and power of C is 100 watt. Right? More power, more brightness. So we can draw an order of that brightness. Power of C is maximum. Obviously, brightness of C will be maximum. Then after, brightness of bulb B. Then after, brightness of bulb A. So this is the order of the brightness in case they are connected in parallel. Now let's see the options. As you can see, brightness of all the bulb will be same. So incorrect. Brightness of bulb A will be the maximum. No, it's minimum. So it's also not correct. Brightness of bulb B will be more than that of A. Brightness of B will be more than that of A. So it's correct. Brightness of bulb C will be less than that of B. It's not less than, it's greater than. So it's also incorrect. So guys, now you can check the correct option. The correct option, as you can see, is brightness of bulb will be more than that of A. So guys, if it is in parallel, so it is very easy to compare their brightness, because just you have to check the brightness by their power, because in case of parallel, all the bulb will have the same potential. Now, what will be the answer of the same question if that combination is not parallel? Means if I change the question just parallel to series. If all these things are same, but I will say that if they are not connected in parallel, if they are connected in series, then what should be the answer? So again, let me solve this question for you, because in case of series combination, they will not have the same voltage. But in case of series, they will have the same current. So let's see how the question will if the connection is in series. So suppose the question is again same, but the combination is series. So how you will compare this? Let's see. Now, as I told you, if these bulbs, their resistances are like this resistance, so can say RA, this resistance RB, this resistance RC. These are the resistances of the bulb, and this bulb is supposed to be BA, this bulb is supposed to be B, this bulb is supposed to be C, right? And now you can say in all these bulbs, current will be same. Now, which formula we should use for the power? Power, if the current is same, we can say P is equal to I square R. If current is same, so the power is directly proportional to resistance. If power is directly proportional to resistance, means the more resistance means more power, and more power means obviously more brightness. So more power, more brightness. How you will see? How we'll check? Let's see. Bulb, power of A, as you know, 40 watt. Power of B is equal to 60 watt, right? And then you can see power of C is 100 watt. So how you will check, how will find the resistance of a bulb? Because in case of bulb, the resistance will always constant. Okay, but the power consumption and the voltage applied to the bulb will change. So we have a relation for power. P is equal to V square by R. And then we can say R is equal to V square divided by P. So now if V is same, so we can say R, resistance of the bulb, is inversely proportional to power. Right? If resistance is inversely proportional to the power, means more power has less resistance and less power has more resistance. So what you can say? Power, minimum power, maximum resistance. Maximum resistance, here you can say maximum resistance, maximum power. Maximum power, maximum brightness. So let's see. Maximum power, 100. So bulb C has maximum power, so minimum resistance. But bulb A, minimum power, as you can see, Bulb A, minimum power. So maximum resistance, maximum resistance, maximum power, maximum power, maximum brightness. Obviously, the brightness of bulb A is maximum. Correct? Then after, more power of B, less resistance of B, right? Less resistance of B, so lesser power. So you can say less power B. Then again, you can say less power of C. Now, the order of the brightness is like this, correct? So, A maximum, B, C. A, B, C, right? So, let's check the option and which is the correct here. Let's again write BA, where brightness of B, then brightness of C. Now check the answer. As you can see here, brightness of all the bulbs will be same. No. Brightness of bulb A. See here, brightness of bulb A will be the maximum, obviously. So it's the correct answer. As you can see, it's already highlighted. And then brightness of bulb B will be more than that of A. B not more than is less than A. That's why it's not correct. And then D option, brightness of bulb C will be less than that of B. Brightness of C less than that of B. Obviously, this is the correct answer. So now you have correct answer. So in this case, if the same question of that NCERT exemplar, if the bulbs are connected in series, so we have multi-correct options, means B and D are the correct option. Okay. So guys, this is all for today. For more such videos, please share and like and also subscribe our channel. And in coming days, I will be solve more and more questions for NCERT exemplars. Thank you. Bye-bye. All the best.